Now, in order to properly manage our environment, we want the ability to control what goes into the routing table and what goes out of the routing table. And we're going to look at routing policy that controls that in this nugget. We're also going to take a look at just some of the firewall functionality that you're going to find on most Juniper equipment. Let's refresh ourselves on how the routing information gets populated on the Juniper device. We know there is a route table, and that is in the control plane. So there is dynamic and static route information coming in the route table. There is dynamic and static route information going out of the route table. And we can control this with import and export policy. Remember, of course, the routing table creates the forwarding table in both its control plane and then copies it down into the data forwarding plane. So if we control what's coming in and out of this, we therefore will impact how the device forwards traffic. There are default import and export policies, and I might want to note for you, the export policy is obviously going to work only with active routes. So for instance, if you have a particular prefix and it's being learned by OSPF with a great preference value, and you have that same prefix being learned by BGP, by default the BGP one is going to be inactive because of the preferred preference of OSPF. So when you do an export policy, you are manipulating the active OSPF prefix, not the BGP prefix. Now, there are, like I said, default import and export policies for our protocols. For instance, if we look at OSPF, sure enough, by default, the import policy is to accept all. Yeah, all the OSPF prefixes we're learning from neighbors are going to be accepted by default, and they're going to be placed in the inet.0 route table. The default export would be to take everything from the protocol and flood it. Sure, so by default, we're going to take all of the OSPF LSAs that we know of, and we're going to export those. So the default operation of OSPF is different from the default operation as dictated by routing policy with RIP. With RIP, we'll accept all from an import policy perspective from all of our configured RIP neighbors, but from an export perspective, we reject everything. So we have to go in from an export perspective and say exactly what prefixes that we want sent from a RIP perspective. So we need to be aware of routing policy because it has a huge impact on what is being shared throughout our dynamic routing protocol environment. Now, I think you're going to be super impressed at how easy it is to manipulate this sophisticated routing policy approach. If we go to Juniper device here, we see that we are learning OSPF prefix information from Juniper device 2 that we have an OSPF neighborship with. Let's go to Juniper device 2. Let's create a static route and let's ensure that gets exported as part of the OSPF information that Juniper device is sending our local Juniper device right here. So this is a very real world manipulation, of course, where we want to disseminate static routing info. So here we are on our Juniper device 2, and obviously the first thing that we're going to want to do is create the default static route. So I'll say edit routing options, and we will say set static, and we are interested in setting a static route. The destination is zeros with the /0 for our default static route. And we want to set the next hop for this static route. Oh, I'll just make something up. Let's say it's 10.10.10.100 as the next hop. So now that we've got our static route on this device, let's go ahead and create a routing policy configuration that will get this default static route into OSPF. To do this, we go into our policy options area. So I say edit policy options, and we are going to set a policy statement named DEFST, and this is going to have a term in it called my term 1, and this particular term is going to match certain criteria. You see, with a policy statement, we're creating if-then statements in order to control things. The if is a from statement, and that's our match criteria, and the then is literally called then in the syntax of the Juniper router. So set policy statement, we name it, name our term, from, what do we want to match? Well, our protocol needs to be static. So there we go, protocol static, and we can then specify a route filter so that we match on our specific static route. So I'll say route filter, and we are going to match on 0, 0, 0, 0, /0, and we want an exact match. Notice there's all kinds of syntax you can use with your route filters. You could do an address mask statement here. You could go longer or longer, through, up to, so you can get super specific. You could say, all right, you need to match on this stuff or longer, meaning the particular mask is greater than or equal to the prefix length that you specified. In our case here, we want an exact match, and there's a keyword for that. I love it. So I hit enter here, and let's just see what we have so far. So we have a policy statement called DEFST. There's a term in it called myTerm1, and our matching criteria, our if statement, if you will, is it's got to be static as far as the protocol goes, and it's got to match this exact prefix. Well, we need our then statement. We need to specify what's going to happen. I'll hit up on the keyboard, and that'll, give us a lot of our syntax already in here, where we are stating what our policy statement is, what our term is, and then instead of the from criteria, we're simply going to say then. What are our actions that we can take? Well, we can accept the route. As you might guess, another option down here would be to reject a route. So in our case, we want to accept it. If it matches a static route, and specifically the default static route exactly, then we're going to accept it with this routing policy. So we've created the routing policy, but where does it go? Well, in our case, we want to assign it to OSPF. So we simply say, let me exit here. I say edit protocols OSPF, and we come in here and we say, we have a export policy that we want to set. So set export, and ours is called DEFST. And let me verify that is correct by looking at our configuration. Yes, that is what we named it. So we are going to set the export policy of DEFST, which of course grabs matches on a default static route and is going to accept that into the OSPF protocol. It's actually sending it out of the OSPF protocol, isn't it? So what's going to happen on our neighboring device is we should be learning through OSPF a default static route now. Let's do our commit and quit. And then all that's left for us to do is slide over to the Juniper device neighbor and see its routing table. So here we are on the neighbor, and we do a show route for the protocol OSPF, and we're looking for a default static route inside that particular portion of the routing table now from our neighbor, and that's exactly what we received thanks to our configuration of routing policy. Remember, the routing policy is powerful if-then statements that we can control exactly what is going in our routing table or what is coming out of our routing table. Now, if you're new to routing policy on the Juniper devices, and specifically that routing policy syntax, great news, we're going to review it right now because we use the same syntax, the same type structure for our firewall filters. Great stuff. The firewall filter is going to be stateless on the Juniper device. And what we do is we create a firewall filter that consists of terms, just like we saw with our routing policy. We have from for matching criteria, and then for setting particular actions. We have to have 0 or more match statements, that's the from, and we have to have 0 or more actions that we take, that's the then. These things are processed in order, these terms. So maybe we have term 1, no match there, then it goes down to term 2, no match there, then it goes down to term 3. And there is a default term that is utilized with our firewall filters, and that is to get rid of everything. So if we don't have a match, the traffic would be dropped, for example, because of the fact that we didn't match any of the terms above. So you have to keep that in mind when you're constructing these things. Also, you have to keep in mind the importance of the order, since they are evaluated in order from top to bottom. What are the types of things that we can do in our then statements? What are the types of actions? Well, certainly we can accept traffic. We can reject traffic, sending ICMP messages back to the source. We can discard traffic. We can log traffic. We can count packets that are matching this particular filter. We can send syslog messages about the traffic. So lots of potential actions can be taken. So let's examine how we would do this on a Juniper device. So we would obviously go into our edit mode, and I would edit the firewall family for iNet, for example, to control our IPv4 traffic. We will set filter, and we'll give it a name. How about my filter, because I'm so creative with my names. And then we create a term, and that term might be block, for example. What are we going to block? That's our from statement. Notice the options that exist here. We can match on all kinds of things like ICMP codes, fragment offset, destination port, obviously source port, source address. You suddenly see that, wow, we're matching on the header fields for IP. Pretty cool. So I'll go ahead and just give an example here. I'll say we're going to match on source address, and maybe the source address is 10.20.20/24. Sure enough, once we've set up our from, we're going to set up our then. So I'll up arrow, and I'll come all the way back here, and I'll say then, and we can see our potential actions: accept, reject, we can do policing, we can do all kinds of sophisticated things. So here in our example, I want a then statement that discards, for example. Maybe I want to do multiple actions. I want to log it and then discard it. No problem. So we just list those particular terms. So I'm going to say then log discard. And we are ready to verify this. Oh, wait a minute though. We don't want to discard everything else. So we better come up with another term inside of this particular filter. So we're going to come back here and we're going to say term, and I'll say accept all. And this particular term is just going to say then accept. All right, we're ready to verify. We do a show. So we have a filter named myFilter. There's a term inside it called block. We match with our from on the source address 10.20.20/24. Then we log it and discard it if it's from that particular source address. Then we accept everything else in this particular firewall policy. Pretty cool. Now, how do you make this work somewhere? Well, we go to an interface and we assign it, either inbound or outbound. So this is super simple. I'll go to the top of my hierarchy. I'll say edit interface, and the interface I'm interested in editing is gigabit 0/0/0.0, and we're editing now unit 0. Great. For the family iNet, we want to go ahead and set up a filter. Our filter is called myFilter. And what direction do we want to do this in? And that's something that we need to specify before we specify the name. So set family inet filter, let's say it's an input filter, and then we can go ahead and provide the my filter name. Notice how the context sensitive help is so cool. It goes and looks for any possible filters you may have set up and displays them for you right there. So the context sensitive help is super smart. It can go out and find those particular variables that you've set up. Let me do a show here to make sure we got this right. So for Gigabit Ethernet 000 unit 0, we do indeed have an input filter in place called my filter. And then, of course, we have the IP address on that particular interface. So that's how easy it is to create these filters and then assign them to a particular interface in a particular direction. Now, before we wrap up here, I want to demonstrate another powerful security filtering-like feature that you are responsible for, and that is unicast reverse path forwarding. With unicast reverse path forwarding, what you do is you have the router dynamically check incoming packets. This is a spoofing prevention system. So the Juniper router is sitting there, and let's say it has a gigabit Ethernet 000.0 interface like we do, and it has packets coming in here. It will look at the source address of those packets and make sense that it could be coming in from that interface. So if someone has spoofed their source address out there and it's some weird address that doesn't make sense per the routing table to be coming from that direction, the information can be discarded. If you want to do other stuff with the information, by the way, you can set up what's called a fail filter for the reverse path forwarding feature, and you can do something else. But by default, we're typically comfortable with dropping that traffic. Now, how do you configure this cool unicast reverse path forwarding check? Well, it is unbelievably simple. Notice I'm editing unit 0 on our gigabit Ethernet 0/0/0 interface still. We could say set family inet, and you just say RPF check. That's it. So it's going to realize, all right, we need to do the RPF check on this particular interface. Once again, we'll show our configuration. Now we see we're filtering certain traffic. For some reason, we want to punish traffic coming from a particular subnet into this interface. And we also want to, on all the other traffic, do an RPF check to make sure it makes sense that source address is coming in this particular interface. So now you are armed with very powerful controls. You can control what's coming in routing tables, what's going out of routing tables. You can control what's happening with transit traffic on your particular Juniper device. Traffic that's trying to flow through it. You can easily influence that traffic with firewall filters. This is another one of those nuggets where we have covered a lot of information. So you may want to review this particular nugget again, or at the very least, you're going to want to run through the appropriate flashcards that I have available for you in the Nugget Lab files to make sure all of this information really sticks. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.